Today's is an electric society where at the flick of a switch there's an unlimited choice between simply millions of products and services. When we're done with these products, we simply dump, and the resulting mountain of waste is buried so it can rot away. However, the very electricity we use to make all these products creates a new kind of waste that's more difficult to handle as it's radioactive. This waste is produced all over the country. It can last thousands of years and can be dangerous if not handled correctly. Nuclear waste. Nuclear power stations, hospitals and defence establishments all produce tons of nuclear waste. It's all gathered together and sent to the west coast of Cumbria, where a £3 billion chemistry set has been specially built to process it.
I'm standing in the middle of a place few people are allowed to enter. This is Sellafield. It's an excellent place to find out about nuclear waste because the scientists and people who work here are the world's leading experts on nuclear waste.
Sellafield is vast. It's the world's leading depository for nuclear waste, and it's managed by over 10,000 dedicated specialists.
The guy whose job it is to know all about radioactive waste is Alan Moses, shift manager here at Thorpe Reprocessing Plant. So Alan, what exactly are the risks involved with dealing with this stuff?
Well, the risks involved can be very severe indeed. I mean, we work in close proximity to the radioactive waste, therefore we have to take our safety issues very seriously indeed.
What exactly goes on here?
What we have here is a nuclear reprocessing facility which takes spent nuclear fuel from around the world, reprocesses it and regenerates new fuel.
And what are the byproducts of that process?
The byproducts of that are actually waste, and there's three types of waste that we have. We have low-level waste, intermediate-level waste and high-level waste.
To illustrate, our low-level waste is composed of shoes, gloves and protective clothing. Intermediate-level waste comprises spent fuel rods, used equipment and materials from decommissioning old power stations. High-level waste is made up of spent fuel and is the most radioactive and difficult to handle. It generates heat and emits 10 times more radioactivity than intermediate-level waste.
So, how do we minimise the risks?
We minimise risk by shielding the fuel. We shield the fuel by transporting around in big steel flasks that weigh 100 tonnes. Inside the flask we have steel liners, and inside the steel liners we have the fuel.
And does the radioactivity change over time?
Yeah, the radioactivity does change over time. It actually reduces.
So how long would that take?
Oh, that can take from 5 seconds to thousands of years. But to understand that, you have to understand how the atom works.
Each atom can only decay once. Its nucleus emits radiation as it changes to a more stable form, so gradually there are fewer and fewer of the unstable atoms. As a result, there is less and less radiation. So at first there is a lot of it, and it emits a lot of radiation. However, as it decays to a more stable form, there is less and less material producing less and less radiation.
Away from Sellafield, others have an entirely different view of the nuclear industry.
I've come to Greenpeace, an organisation that's long been concerned with nuclear waste and the harm it can cause if not dealt with properly. Jim, why is nuclear waste such an important issue?
Well, nuclear waste is particularly important for humans and the environment because it can be very, very damaging. This radiation can basically damage the cells as it passes through our body, or if it gets inside our body, it can seriously damage us, which can lead to cancer of various types. It can do the same in the environment across the board, and too much radiation in the environment will begin to destroy species and potentially make it an unusable environment where human beings can't go. It's not like an organic material that you just put it in the compost bin and it rots down. This is a substance that lasts thousands of years, a substance that emits radioactivity. People are trying to find ways of disposing of it in such a way that it won't harm the environment and it won't harm human beings. And we don't have a solution for it. So what we're looking at, and the industry's been looking at, is trying to find ways of storing it, but only of storing it so far. There isn't an actual solution to the waste problem we have.
Just storing the waste in containers or storage ponds is only one of the ways the nuclear industry deals with its waste. They also store the high-level waste by trapping it in glass.
Small granules of waste material are mixed with granules of glass and then heated till the glass melts. This traps the waste in the glass, a process called vitrification.
What is produced is a mass of glass that contains the waste. This is a small model of what it looks like. The advantage of storing it in glass is that even after many thousands of years, when the outer steel casings and the concrete have crumbled away, the glass remains intact, so the waste can't leak or seep away, which is great.
Because this high-level waste is the most dangerous, it's housed in an immensely secure area. The vitrified waste is stored in large drums, which are handled by skilled technicians in a closely monitored and safe environment.
Now, Clive, you're working with these radioactive materials, which we know can be dangerous. How comfortable do you feel with that?
I'm really happy. Basically, we are working with high-level waste back there, but it's immobilised in a glass matrix, so it's basically safe.
Is that what keeps us safe then?
No, that basically keeps the activity in one place. The reason why we're safe here is due to the shielding provided by the wall here. There's around 2 metres worth of material there that's protecting us from the radiation.
Okay, so how do you measure how much radiation you're receiving then?
Basically, we use dose meters here. This basically shows that we're getting very low levels of radiation coming through here, in fact 0. That's against an annual legal limit of around 10 millisieverts.
What sort of dose would you receive if you were in there?
Well, I'll put it like this, if I was to be in there, I wouldn't last more than a few seconds.
So you clearly can't go in there and work. How do you get around that?
What we have to do is use a set of innovative techniques, such as this robotic arm, to enable us to work at a distance in the cell.
And that keeps you nice and safe, which is great. But what's actually going on in there?
What we're doing here is checking for surface contamination on a container. To do this, we rub a swab over the whole surface and then check it in a monitor to see how clean it is.
And how clean's the container that's in there now?
It looks very clean. We'll be able to send this to store very soon.
Every single drum of high-level waste is numbered and logged before being sent to Sellafield's high-security storage facility. At the other end of the scale, low-level waste gets the same treatment with the same attention to detail.
The waste arrives here where it has to be sorted and checked before it can be dealt with. Now, Andrea's a bit nifty at this, aren't you?
I should be. I've been doing it for quite a few years now. What we do is we sort through the bags so as we can see what's in them, and then they go on a conveyor belt down to the compactor.
Great, let's see you in action.
Yeah, I'll show you what we do. What I'm doing at the moment is I'm removing some waste from the trough and placing it into a box.
And what's inside these bags? What kind of waste is this?
It's general low-level waste, which is paper suits, gloves, wellies, tissues, just things like that.
Right, what happens next?
It then goes down to the compactor where it gets squashed using tons and tons of pressure into a puck.
So that's a puck, is it?
Yeah, it gets squashed down to about 1/5 of its original volume so that we can fit round about 100 pucks into a container.
And what happens to the containers?
It then gets sent to Drigg where it gets filled with concrete ready for storage.
So, Nigel, we're here at Drigg. What exactly goes on here?
Well, the containers of waste that we saw being filled up at Wamac are brought here to Drigg where they're filled with concrete, and then they're placed in this large vault behind us. Although it doesn't look like it, each of those square shapes you can see behind me is in fact one of those waste containers. Once the vault is full, it'll be capped over with clay soil and it'll be looked after for as long as society deems necessary.
Great, so we know what's happening here. Now, how about you? Do you enjoy working in the nuclear industry?
Yes, absolutely. It's a fascinating sort of a job. It's quite rewarding. What more can I say? I've been in it nearly 20 years now, so yes, I do enjoy it.
Do they pay you well?
I do get paid well. The industry expects high professional standards of its employees, so naturally that comes with the appropriate rewards. And
Do you have people queuing up to come and work here then?
I'd like to say we did, but like all technically based industries, we do actually need more geologists, scientists, engineers. There are a whole range of challenges the industry faces, dealing with the waste like you see behind me, dealing with the old facilities. So we do need more engineers and technicians and what have you. You don't have to be a boffin to work here. There are a whole range of practical things people can get involved in.
The average nuclear power station can operate for over 30 years.
When those old power stations come to the end of their useful life, they have to be taken down. This is a process we call decommissioning. However, taking down something like this isn't quite as simple as you'd imagine. Terry, tell me what kind of challenges you face in taking something like this down.
Well, our biggest problem is the radiation coming from the core and the pressure vessel. That radiation comes from the activated components of the reactor. All the fuel has been taken out some 20 years ago. So all we're left with are the structures themselves. They weren't radioactive when we built the reactor. The actual operation of the reactor during its lifetime has caused them to become activated, generating a lot of radiation. The radiation dose rates coming from that material are so high that we can't get anybody anywhere near it. And so we've had to convert the plant over about the last 15 years for full remote operations. And all that system is operated from this control station. And you can see the operator's got a whole load of CCTV screens so he can see what he's doing. And those two machines are operated with joysticks, much as you would operate a computer game.
So, Julie, tell me what you've just done there.
What we've just completed is a cut using the gas torch tracking system, which has cut a piece of waste that is on the reactor floor as such, which is called the diagrid.
Right, and what is it you're doing now then?
What I'm doing now is just lifting the piece of waste to the waste route where it will be placed.
Removing this kind of intermediate level waste from old power stations is a long and difficult task. The government is setting up an organisation called the Nuclear Decommissioning Authority. It will be responsible for managing the clean-up process and ensuring it's carried out safely, efficiently and in ways that protect the environment. At the moment, we have 100,000 tonnes of intermediate level waste, the equivalent of filling Manchester United football stadium to a level of 12 metres. When decommissioning is fully completed, that waste will grow to a staggering 400,000 tonnes.
As we heard earlier, intermediate level waste makes up a significant proportion of the radioactive waste we have to dispose of, and it can be made up from different source materials. Although it's not as radioactive as high-level waste, it still poses a threat to humans if it's not dealt with safely. This is the kind of thing that makes up intermediate level waste. These are the casings that are left over when the fuel pellets inside have been dissolved away using nitric acid. Metal tubes like these are radioactive because they've been contaminated with fission products. However, no matter how much effort the nuclear industry makes, some people are still not happy with the way they deal with it. Campaigners for Greenpeace maintain that we should not generate future electricity from the nuclear industry, as the financial and environmental costs are just not worth it.
Nuclear accidents have happened in the past. In 1986, nuclear workers at Chernobyl ignored safety warnings and their reactor overheated and caught fire. The cost in terms of both human life and environmental damage was immense.
Jim, what are the implications of Chernobyl?
Well, Chernobyl was obviously a freak accident, and it's the worst accident there's ever been in the history of nuclear power. But it wasn't nearly as bad as it might have been, in actual fact. It was an accident that came about through human error mixed with technological error. But as it was, only about a quarter of that core melted due to some heroic actions by those who were working there, who basically sacrificed their lives to make sure the whole core didn't explode. So it was only about a quarter as bad as it might have been, and yet we still had a radioactive plume that spread as far as the USA, definitely to the UK, up to Scandinavia. In fact, there are still parts of the UK that can't be found because they're still contaminated by the radioactivity that came out of Chernobyl.
That's obviously a worst case scenario. Now, what sort of dangers might face people like you and me on the street?
Well, we have something like 15 to 20 nuclear sites around the country. Not just power stations, but also Sellafield, which processes that kind of power, the wastes. And Sellafield itself is the most radioactively concentrated place in the world. There's more radioactivity in Sellafield than anywhere else. And there's obviously transports that go back and forth from the stations to Sellafield, taking between 1 or 2 tons of waste. And in terms of the damage it can do, well, it's not going to explode, hopefully, but what it might do is emit itself. Radioactivity is routinely discharged from every power station, both into the sea, into the air, and onto land, and human beings. So every day we are exposed to discharges that come from the power stations and the transports that are affecting us in ways that we really don't understand.
Environmentalists believe that any level of nuclear radiation is unsafe. The Environment Agency and Nuclear Installations Inspectorate work closely to ensure levels of emitted radiation from nuclear sites are below prescribed safety limits. In addition, the government has now decided we need to address the nuclear waste problem head-on. This is the centre for trying to find that solution.
After all I've learned, I for one would love to know what they think can be done with nuclear waste. Hi Jenny. So explain to me what you do here then.
Well, we're an independent committee that's been asked to look at the long-term solution for the management of high-level and intermediate-level radioactive waste. And you know there's no solution for managing that waste at the moment. We've got a very long name. We're called the Committee on Radioactive Waste Management. We're going to be running a public consultation process to get the public's views about the solution that they have the most confidence in, and then we'll be recommending that to government. It'll be up to government to decide whether or not they want to accept what we say.
So how close are we to a solution?
We're not at all, because we're only just starting off the process. So at the moment we've got 14 options that we've identified. That's quite a lot, and I would imagine we might get some more from other people. Some of them are things like dumping the waste at sea or sending the waste up to space in a rocket. Others are things like building a repository, a hole under the ground where the waste could be put, or perhaps storing it on the surface where it could be monitored.
But whatever solution we find, there's always going to be a risk, isn't there?
Well, we're looking at risk, and we're looking at how we manage risk, and that's part of asking the public, is to find out what they think is an acceptable risk for us to manage, because obviously the solution has to be one in which the public has confidence. But it's got to be safer than what we've got at the moment. We've got lots of this waste here, and we've got no strategy for managing it, so it's got to be better than what we've got now.
So it's up to us, the public, to get involved then?
Exactly right.
This consultation process with the public is about finding an acceptable way of dealing with nuclear waste. This will help our government to decide what should happen to our nuclear industry. We may continue to close our nuclear power stations, or we might decide we still need nuclear power and start building new and more efficient ones. Whatever we do, we must find a solution to the here and now problem of nuclear waste. It seems to me that storing nuclear waste for thousands of years may not be a safe future solution to the waste management problem. No one's lived long enough to know what state the waste stores will be in 5,000 years from now. What the nuclear industry really needs is to uncover a long-term solution to the problem, and it needs teams of scientists, engineers and technicians working together to achieve this. Maybe one of you watching this programme will be in the team that finds that very solution.